My name is Wayne Fagan. I'm chair of D. Howard International Education Foundation. I'm here today with our partners at University of Texas at San Antonio, Cleese College of Engineering and Integrated Design. Carlos Velez is on the line with us representing UTSA. And we are going to be presenting as part for our October 2022, I'm sorry, I said that wrong, November 2022 rural school virtual presentation to Frankfort Elementary in Frankfort, Missouri. So a couple of technical details. Hello, kids in Frankfort, Missouri. Great to be with you. So a couple of details. If you're not, I think to save bandwidth, if you're not speaking, if you would go on mute, and if you are not speaking, if you would also go off of video, and that will save the bandwidth for everyone else. And because we got a late start, maybe if we go to everyone to 2:45, would that work? If we go to 2:45 for presentation by our presenter, and then we'll have 15 minutes of questions and answers with the students from Frankfort Elementary. Does that work? Okay, so with that, I want to welcome our students from Frankfort Elementary, and I will turn the program over to Carlos Velez, who is Diversity and Outreach Program Manager at UTSA Cleese College of Engineering and Integrated Design. And with that, Carlos, I'll turn it over to you and you can introduce our presenter.
Absolutely. Thank you very much, everybody, for having me here today. So as Wayne had just mentioned, my name is Carlos Velez. I'm our program manager here for our Cleese College of Integrated Design. I work here in our Student Success Center. So within our office, we help people with professional development. We work with student organization projects. We host engineering summer camps and do a lot of great things within the field and help our students currently be successful in their academic endeavors. So we're happy to be a part of this initiative and to introduce engineering out to K-12 schools throughout the country. And with that, I'm just going to jump right in so we can get everything over to Dr. Votion. And so that we have enough time today, I'll be helping moderate and do any questions and get everything over. But with that, I'm just going to pass it right over to Dr. Votion. You'll probably be able to introduce yourself a lot better than I have. One of our great faculty here at UTSA. So Dr. Votion, take it away.
Hi, everyone. I'm really happy to meet all of you. Let me go ahead and get my screen shared. I'm going to be sharing this with the sound. And I'm going to share that. Okay. All right. So, yeah, I'm just going to go right into it. I'm here to discuss drones with everybody. I hope all of you are interested in technology, and one really interesting aspect of it is drones. And drones are a really powerful tool that we use every day. So a little bit about me first. I was born in San Antonio, Texas. So I was born here, in San Antonio. This is where UTSA is, University of Texas at San Antonio. I'm showing a lot of little cities here, so I hope you could make out where San Antonio is on this Texas map. Here's a picture of San Antonio. So it's not a super large city, but we do have a good number of tall buildings. And we also have the Riverwalk, which we are famous for, the nice festive Riverwalk, and the Alamo. So that's something that you should probably learn in history. I graduated from UTSA, so I went to UTSA. I got my bachelor's degree, my master's degree, and my PhD degree, or my doctoral degree. And then the hobbies that I have. So I like to go camping, hiking, and biking. And so this is a picture of me I'm actually camping and hiking at the Santa Fe Forest in New Mexico. And this is a trail called the Hermit's Peak Trail. Very high. It's about like a little more than 10,000 I think feet in the air. Tabletop games. I really like tabletop games. So, you know, Risk or Monopoly or even card games I like to play. A long time ago when I was small, I used to play Pokemon. So I don't know if any of you kids are interested in Pokemon still. And then just any kind of tabletop games. There's all sorts of games. So I also like eating in movies. I love to eat and finding good places to eat and going to new places and new cities and looking on the internet for what's the best place to eat around and going to those specific places. You know, I really want an experience. And then movies. Here's one of my favorite movies. It's called Interstellar. And what's really cool about this movie is it actually put a lot of money into the computation for the physics around a black hole, so outer space and black holes and planets. And so the science and calculations and computations that they put into making the graphics for the movie of a black hole, actually NASA used that and were able to create or make a lot of new findings. So that's just something really interesting about that Interstellar movie. And it's a really cool movie about the future as well. A little bit more about me. So what do I do for work? I'm an assistant professor of instruction here at UTSA. Some of the courses that I teach and help out with are a course called the ECE Capstone Design course. That's one of the last courses that electrical and computer engineers take as part of their undergraduate program. And in that course, they build unique products and devices, and it's just really interesting. I have teams that are building drones, teams that are building some AR applications, and I had a team, they're building just a smart cane. It's a cane to help the blind or the visually impaired in order to get around. So they're going to be putting a lot of cool sonar and other sensors in it in order to tell them when they're not getting close to objects. So here's just a picture of UTSA. Here's a picture of the Science and Engineering building where we have the makerspace. So this is one of the places that I work. Right next to it, I promise it's about 10 or 15 feet away, just right across the sidewalk, is the BSE. So this is where my office is. This is where I'm actually giving the presentation right now. And then also with the EPICS program, this is a outreach program where we work with community partners, nonprofit partners. And so one of the nonprofit partners that we work with through the EPICS program is the Museum. And the museum here is the San Antonio Children's Museum. So it's one of the, I think, largest children's museums in the nation. Okay. And then my research interests. So what are the things I like to research on? We're going to get into this, but it's called UAV autonomous navigation, and then path planning in uncertain environments. So here, what I have shown is a picture of the USL lab. It's called the Unmanned Systems Laboratory. And what you'll notice is there's a big, basically like a caged area or a netted area. And so in this area, we'll test out small unmanned vehicles that take flight. And if you really look closely, you'll also notice that there's these little blocks around the testing area. These are cameras. So we use the cameras, a big giant camera system. It's a motion capture system. So if you know a little bit about movies and how they make motion captures, they use people to do the motion. They capture that motion and then put it into animation. This is the same type of camera system that we use for flying the drones. And then here are just some of the drones that we have in the lab. I'll be showing you some of the drones in a short while here as well. And we have this fixed wing plane. And then we just have more work areas. So this is from the SCV, this picture in the top left corner. and yeah, this is, you know, the university here is very large. I'm only showing you 2 out of maybe the 20 buildings that we have on campus at the main campus. But we also have a downtown campus that we're opening new buildings on. And, you know, as far as STEM and technology, you know, it's a really good field because we're a growing field. We're able to open all these new buildings because we keep growing, and that's a good sign, right? A good place to be. What I also do is I do some outreach activities. And so one of the outreach activities that we had was a drone competition that we put on a few weeks ago on October 29th. In this competition, I was responsible for bringing a few activities, and the activity that I brought was a drone activity. So students are able to fly drones, and this particular drone that we're going to show you has FPV capabilities, and FPV stands for first person view. And so not only can they fly it, you know, just line of sight by seeing where they're flying, but they also could look at the screen and get a more in-depth look at what the drone is going through.
Yeah. Don't forget that you can rotate the axis of the drone. Yeah, there you go. There you go. Oh, we got 1 minute. Can we go for 2? Go switch. And so you're actually, yeah. Well, so you actually need to understand where the drone is, like in the cage, and then turn. That's why I like recommend like standing here and then going this out, and then you actually go forward, and it's like. So if you look at the drone, you have like the top slope and the
costumes, you know. Okay, I hope everybody could hear that. I'm pretty sure I have the sound engaged. So if you did not hear that, please someone let me know. I'm just going to continue from here though. So what are drones, right? Enough about me, enough of what I do, enough of what I do for outreach. You want to know what are drones. So what are drones, right? And what we call drones here in academia and in the industry, we call them unmanned aerial vehicles because they're vehicles that fly in the air, aerial, and they are unmanned, as in there's not a person sitting in the vehicle while it's in flight. Okay. And so we have some drones or quadcopters or UAVs, whatever you would like to call them. And so first I wanted to show you this Holy Stone mini drone, right? And so this is a $37 drone that you can get off of Amazon. These are one of the drones that we use in the drone competition activity where we allow students to fly the drone through the obstacle course. And it's just a small guy, right? It's just a guy who, it's just a little one that just fits in your hand like this, okay? And so this is really good, you know, for starting off, for just learning how to fly and just having fun. The batteries though, you know, with drones, the battery and the weight of the battery, we have to consider that. So we use a very small battery because it's a very small drone. And this will basically last you, the battery will, depending on the size of the battery, 4 to 5 minutes in flight, right? The next one we have, which is the one we showed on the video, is this Tiny Hawk 2 by Emax, but actually this one's called the Tiny Whoop. And so again, this is a little guy. The difference between this one and the other one though, a big one, one is the quality of the motors is very much improved. And the other one is, this one has a little camera on it. So that's why these can go anywhere between $140 and $250. It also comes with this like FPV kit. So you could put this on and look at it through first person view. And the controller is a little more involved as well. Okay. Okay, so let me put on that. Okay, I lost my tracking, but it's okay. I'll keep going. The next one I wanted to show you was this Bebop. Again, this Bebop is going to be a little bigger. It's around the same price. And so this is the Bebop, right? This is a bit larger. It also has the front-facing camera. And what it also has on the bottom, which the other one didn't, it actually has two sensors. There's a small camera, which you're not going to be able to see very well. But then there's also this ultrasonic sensor. And that basically lets it know the distance from the ground. So an ultrasonic sensor senses the distance between the object in front of it and the sensor. So now we could know how high it's flying off the ground. Okay. The next one we have is the cue ball. So to be honest, I don't know how much this cue ball costs. It could cost anywhere between $2,000 and I think $15,000. I'm not quite sure. But this is the cue ball behind me. It's sold by Quanzer, which is like a research company that builds drones and other robotics. So see, this one's a big one, right? And we also can go by the size of the propellers as well. Okay, this one's really nice. It has this cage around it. What the cage is for is just to protect it while it's in flight and if it bumps against the wall or anything. As well as what we do is we put these IR markers. They're these little balls that you see on just on a few locations here. And those little IR markers are used with that OptiTrack system I was talking about earlier, that motion capture system. So if you go and you look at motion capture, what you'll notice when you do it for people is they have a special suit where they wear all black. And then on the black suit, they have these small dots, these markers, and those are the IR markers. So we use a similar approach, and we use the IR markers with the motion capture system in order to determine exactly where the drone is flying within that environment. Okay. And then last but not least, this one's another one you could buy off of Amazon. This one's over 2,000. I think this one's almost like $3,000. This is a hexacopter. Again, this is a very large, probably just as large or a little larger than the one I just showed you, the cue ball. And you know, it's a really nice approach. I just wanted to show you another option there. Okay, but not only these type of, you know, quadcopters is what we call the drones that have 4 motors and 4 propellers. And then the one with 8 motors and 8 propellers is called a hexacopter. I'm sorry, that's 6. 6 motors and 6 propellers is called the hexacopter, right? And then we also have the octocopter, which is 8 motors and 8 propellers. And so these are just different forms of the copters, right? The copter drones. But they're not only copter drones. You shouldn't just think of ones with motors and propellers as drones. Not only those are drones, but we also have fixed wing drones or fixed wing unmanned vehicles. And so this is just basically little silhouettes of the different forms that they have. But these are very, very large. These are like military drones here. And so another example of the military drone is this one right here. And so I really wanted to show you the size in that, you know, you see a full-grown man stand by this drone, and it's larger than a truck. It's almost the size of an 18-wheeler. Or, you know, we also have to consider that wing size, which is cut out of the picture. But not only can drones get very, very, very large, but they can get very small. And you think, oh, well, I just showed you this really small drone, right? Well, there are actually smaller drones. And so this is also considered a drone, but it doesn't have any propellers or wings or anything. It's actually, this kind of technology is still undergoing, and we're trying to figure out what's the best way to, you know, incorporate these in real world applications. So maybe if the wind is really strong, you could just throw a bunch of these out in the wind. And actually, these are referred to as smart dust. So that's also a drone. Okay. But more than what are drones is what do we think drones are? I'd like to give my perspective on what drones are, and drones are mobile sensor networks. Okay, so think about that. What's a mobile sensor network? A network is just a bunch of things that talk to each other. A sensor is just something that picks up information. And then mobile is just something able to move. So it's a device that's able to move at different locations pick up information and then communicate that information with us or with other drones or with other base stations or with other computers, and that information gets routed to us in some way. So but we are now starting, you know, in the last 5 to 10 years, starting to show different types of drones. We're not only using them for mobile sensor networks anymore, we're now using them as tools to actually do work. So 2 of the examples that I have are, and so these are called effectors because they're things that the robot controls or the drone controls that actually does something. And so 2 of the examples that I have are latches and lights. So do you know anything that uses latches on a drone that they're using now? Well, one of the things Amazon is doing, and I think Google's also doing this, is drone delivery, right? So wing drone delivery. Here's one of the wing drone delivery. This is about 10 pounds. So it looks large, but it's not too large. It's only 10 pounds. It could carry up to 3 pounds load, and then it could make a 12-mile round trip. Okay. The other application for drones that we see here are lights. And so here also is drones that we've that have very strong LED lights on the bottom, and then they work together to make a constellation, if you will, in there. Just like you have constellations of the stars, we could have constellations of drones, and when they activate their lights, they could make images in the air. Okay, so one interesting video I'd like to show you here. Let me play this for you.
倒计时5、4、3、2、1，起飞！
That's really simulated fireworks. Awesome. So I hope you guys thought that was super cool. I think that was really awesome. But not only, okay, so let's go back to what drones are, right? Unmanned aerial vehicles, these mobile sensor networks. And so going back to the mobile sensor network idea, we want to talk more about the sensors part. And so what type of sensors would you think that we want to put on drones and move them around in order to get information? And what kind of information what do we want to get? I think the most obvious answer here is video, right? That's the most obvious one. And so, you know, we could use a video for many applications. I think the best application for this is inspection of infrastructure like bridges. And so we have here, you know, power lines. We use drones to inspect the power lines. If there's a long distance of power line and there's an issue or a problem along that line of power line, how do we find it? Well, someone has to go drive down the power line and see if anything's wrong with it. And then once they find it, oh, okay, they're able to report it. But now if we use drones or UAVs, we can just fly the UAV through there and then have the UAV do that. So we're saving a lot of manpower and using it as a tool. But not only on power lines, but we could do it for roof inspections. We could do it for the pipeline inspections, and we could do it for energy grid inspections, like not windmills, but you know, these energy harvesters. And so another type of sensor that we could come across are infrared or heat sensors. Again, these are used to evaluate power plants or electric grids, or even methane leaks. If you use IR or infrared, you could see the methane come out of certain pipes, so you'll know and find out where the leak is. And then the last one is that I wanted to mention was communication. So we could actually, if we're very far away from someone, we could set up a relay of multiple drones and then communicate them through the drones. So this is what this image shows here. Suppose we're somewhere and there's a source and we're needing, you know, to communicate with our cell phone. What we can do is use a drone, because there's a mountain or a hill in the way, use a drone to bridge that communication. Okay. And there are many other sensors. Like, what do you guys think the sensors should be, and what applications and the information that they should pick up? This is for you to decide moving into the future, I think. So there's always room to develop more and learn more and apply more here. The next topic I want to go into is people who use UAVs, right? So people who use UAVs include industry. So we use, like we just mentioned, delivery. We mentioned security. Well, we haven't mentioned security, but security like police and the military. Infrastructure, that's the one we mentioned, with inspection and construction. Rescue, so the Coast Guard. And then space, you know, NASA, planetary exploration. And so one application that I did want to show you in a little bit is an actual Coast Guard rescue application. But before we do that, I just wanted to show you a diagram basically of all the different applications that UAVs and drones apply to. So here at the top, we have like flight zone, mission, environment. And then, you know, we could divide this between outdoor applications and indoor applications. We could categorize this by environment. Are they gonna, and there are drones, flying drones that do underwater missions. They actually like go dive into the water and come back out. So we could do underwater, we could do water, ones that just land on the top of the water. We could do ground applications, air applications, space applications. And then when we go to mission, we go farther down the mission line. We could divide that into military applications and civil applications. And so, you know, a very popular one is just videography, just getting good videos, you know, for movies or shows or anything like that. Disaster response. And so this is something I'm interested in. How do we use drones and UAVs for rescue missions, right? City government, like we said, inspections. Environment and climate, we could use it as, we could put a thermometer and we could put maybe wind sensors on there, and we could fly the drones around and get a better idea of when a storm is coming or how the weather is changing. Space drones, like I said, space exploration, mining, oil and gas. So underwater mining for minerals, that's a thing now. I have one student who's working on a spider robot to go underground and work undersea in order to mine certain minerals. And then on the military side, we have just a lot of military applications, okay? Okay, moving on, I wanted to show you this video here. So in this video, the story is, I think this was off of the coast in Australia. And, you know, when you're swimming, you have to be very careful on the beach because there's these underwater currents that could basically underwater, like tides or like strong currents that could take you, and that could take you more out into the ocean and make it hard for you to get back to the beach. So they were actually running a test, and just after running the test, they wanted to see how it went, and they ended up actually rescuing.
Can you turn the volume down? Can you turn the volume down that way?
Can you say that one more time, Carlos?
Oh, I was just gonna tell you, if you on the videos, if you turn the volume down like about halfway, we can't hear you over the videos and the audio is loud. So just turn it down.
Oh, okay. Yeah.
Or your volume.
Sure.
But you sound fine. Just the videos are loud, so we can't hear you talk.
Got it.
If not, it's fine. I didn't want to interrupt you.
Okay. Yeah. Let me just Okay, yeah, that was just a short one. It basically was like flying along the coast, and it saw some people that needed help, and it dropped the inflatable raft, and so it saved them. So moving on, so I'm almost like a little more than halfway through the presentation, but these are types of UAVs. So here again, we mentioned the difference between a quadcopter and a hexacopter. But there's also, if you see a fixed wing rotor, so that's just like an airplane, you know, and it has the propeller in the front. We have the tricopter with 3 propellers and 3 motors, hexacopter, quadcopter, the single rotor, which is just like a helicopter. But what's interesting here that I wanted to point out was this fixed hybrid VTOL. And VTOL is an acronym. It stands for vertical takeoff and landing. So what it actually does is it acts almost like a helicopter, and it takes off. And then once it's off the ground, it turns into a fixed wing airplane and then flies like a fixed wing airplane. So that's what VTOL is. And then, so now how do we categorize UAVs? We have different types of UAVs. You could categorize that through weight, through wingspan, or through engine type. And so here, this is one classification table that we have. And so you could see based on the weight of the drone, they classified it as either a nano drone, a micro drone, a mini drone, a small drone, a tactical drone, and then a MALE, a HAIL, or a strike drone, those really large ones, like that large one I showed you at the beginning. And then we could also classify these by wingspan. And then by wingspan, we have these classifications. These stand, so going from left to right, UAV is, the UAV is just a UAV, right? And then this weird symbol UAV, that's called MU, or a micro, so it's micro UAV. And then we have micro air vehicle, the MAV. We have nano air vehicle, NAV, pico air vehicle, PAV, and then we have SD, which is that smart dust, that very small, tiny ones that we have. Okay, at this point, I wanted one of my students just to introduce themselves, give you an opportunity to talk to one of the students, and he's going to go over a couple of slides as well. Okay. I guess, yeah.
Okay. Hey, hi everyone. My name is Michael Buford. Just very quickly, a little bit about myself. So if you guys can see in the top left corner, that's just a little informal picture of me. I have two pets. The one with the pink color, her name is Jinx, and the black one, his name is Shadow. So I'm actually a electrical engineer here at the University of Texas at San Antonio, and I like to specialize in drones, robots, and aerospace technology. So if you guys see on the right, I included this picture of my my living room table and my kitchen table just to show you guys like how advanced and how hands-on you can get with drones, you know, inside of school and outside of school. So sort of going off of what Dr. Votion mentioned regarding the different types of drones, if you guys can see the very first drone with the black and green propellers, that's actually a micro drone. So it's going to be one of those smaller drones with a camera on the front as well. I'm actually very interested and very involved with the FPV technology. Again, that being the first person view technology. So what that is that's allowing you to see from the perspective of the drone. So that's something that I'm extremely interested in. I also included in the bottom left corner a picture of anime. I'm not sure if you guys are into like anime, Pokemon, and things of that nature, but as an electrical engineer, I try to touch on just a little bit of everything. So having a good, well-rounded sense of drone technology and aerospace, but also having a pretty fun and involved entertainment life outside of school. So what I'll do real fast is I'll go through a brief explanation of what drone technology is and how a drone actually works. And so looking on the standard parts that make up an FPV drone. So whenever you're thinking about, how does a drone work? You want to consider the motors. As Dr. Votion mentioned, there are different things that characterize and change the type of drone that you're looking at. Here in the picture, we're actually going to be looking at the breakdown of a quadcopter. The quadcopter consists of a motor, and I'm not exactly able to show, but it's labeled. We have our propellers being the fans that spin. Thank you. We have the propellers, the things that spin. So actually following the diagonal of the drone, and not a lot of people know this, but drone motors don't actually spin all the same direction. So two of the motors spin clockwise and two of the motors spin counterclockwise. And that's what causes the drone to lift up. And so moving in from the motors, we have our ESCs. Our ESCs are going to be our electronic speed controllers. And what those do is those actually tell the motors how fast to spin. So if you guys have ever played with an RC car or an RC helicopter, you know that whenever you're going really, really fast and you know maybe the helicopter or the drone is getting out of control, that's because you're telling it to move a little bit faster or you're changing its direction very, very quickly. And then moving into the center, we have our flight controller. Our flight controller is a thing that's actually sending out those instructions to our ESCs and then to our motors. So as Dr. Votion mentioned, drone technology is just a combination of systems. So we have many different parts working together to create an action or a certain result. And then right above our flight controller, we have our PDB, or a power distribution board. And so this is where we actually connect our battery to, and our battery, depending on its size, provides a certain amount of power for a little bit of time for what we're trying to accomplish. At the very front, we have our motor that allows our camera that allows us to actually see from the perspective of the drone. So with FPV or first person view, sort of think of that camera as being your eyes. So if I close my eyes and the camera is running, I'm only able to see what the camera sees. So if I'm flying based off of my eyes, that's flying line of sight. And so I'm able to see and I'm controlling the drone based off of what I see. But if I'm looking at from the drone's perspective, I'm going to be using that camera. Moving to the back, we have our VTX, or our video transmitter. This is what's actually sending out a 5.8 gigahertz signal from the camera and the flight controller to our set of goggles. Now, that sounds really, really complicated, but think of it like an antenna, right? So we want to send data or information from all of these components to our goggles or something else. So standard technology within drones are going to be a transmitter and a receiver. So things that you input controls on and things that receive that control, whether it be your transmitter or your remote control, and that affecting or that is being received by the drone itself, or if we're transmitting video signal that's being picked up by our set of goggles. So that's a quick and brief overview of how an FPV drone works in a very, very short time span. Right here down in the bottom corner, we actually have a autonomous drone. That drone appears to be flying on its own. You don't see a person involved, which is why it's classified as an unmanned aerial vehicle, or that UAV. And the top corner, we see our Raspberry Pi. Raspberry Pi is just going to be a microprocessor or another replacement for that flight controller. Both of them simply being the brains of the quadcopter or robot.
I just wanted to jump in really quick. I just want to make sure that we do give enough time for our school.
Yeah, I think we're about done right now. So.
Okay.
Absolutely.
So yeah, the last thing I wanted to do is, this is the last slide, was just describe some of the different UAV problems. So some of the problems I've even worked on are autonomy. So how do these drones or UAVs make decisions? Guidance, how do they know where to go? So this is an example of some of my research where we have drones flying along 2 air tracks, and then they're looking at the road network and they only have a limited field of view. And if they're looking for a certain car, how are they going to travel in order to find that car? Energy conservation and communication. So energy conservation is saving battery life. Communication is how do we send big data quickly? Here I've shown an image on the bottom left. What we want to do is, if there's 2 airplanes that are following each other, we want the second airplane to travel in this ring behind the first airplane. And that's due to this drag effect. And we don't want the airplane in the back to experience so much drag. So we're going to try to fly in that ring. And then the last 2 are space exploration, dealing with the harsh conditions of space, and then vision, understanding what we see. And so here, again, just if we have to travel from one point to another point, what's the best way to go? And how do we route ourselves through there with all these different hazards? So that's all I have. I have a few references here, but if you have any questions, me and my assistant will be happy to answer any of them for you. Thank you.
Yeah. So, yep, Frankfurt, if you have any questions, let us know. Feel free to put them in the chat, or if you want to just say them out and ask them. Unmute yourself, you're more than welcome.
But it's not.
What the heck? That's weird. I think it's not connected here. I think it's connected to your webcam. It's connected to your
We see you.
We see you.
Yeah, we see you and hear you.
We see and hear you.
You see me, but I had it fixed in the kids, but that's okay. So first, Dalton's got a question for you. He's going to come over here and ask the question.
Do you know how long it actually took to program all the drones to like do all those like lights and stuff?
Can you repeat the question for him?
Do you know how long it actually took for like drones to do all those like cool images and stuff with all the lights?
So there's the amount of time that it takes to develop the programming and everything. And then there's also the time it takes to perform the flight. I don't know how long that flight was, but given that, drones only have a limited battery life, I would expect that the drone was probably, that flight was probably a little less than 30 minutes to do all those different formations and all those different images in the air. If you were there, it would probably be like a 20 or 30-minute show. But the research that is involved into it, it probably took 2 years, maybe.
Okay.
Thank you. We've got some others that are ready for questions too. Are you ready for us?
Yep.
We are.
But what is connected to this?
Because it's connected. Okay. All right. So come on over there. All right. Sawyer has a question for you.
What is your favorite drone?
I'll let Michael Buford answer that, the student.
Yeah, absolutely. So my favorite drone has to be, this little guy right here. So it's really easy to fly. You can fly it indoors and outdoors. The motors are really, really strong, and the camera allows you to connect to the goggles. So you can fly it around and you can, accidentally run into brother and sister without getting into too much trouble with it. So this is gonna be my favorite drone. And if you fly it inside, you don't have to worry about making mom or dad mad either by breaking something. So one of these guys right here.
Nice.
Cool. I know some of them are putting them on their Christmas list. They have already
Oh,
said
we have
that.
to, absolutely.
I've got Jessica with a question she'd like to ask.
Have you ever fixed a drone?
Yes. So I'm the really cool thing about electrical engineering and what I'm pursuing is all I get to do is fix drones. We get to build and fix drones all day long. So the really cool thing, some of these drones, you can actually buy them either as a kit, pre-made, or you can get the parts to make them yourself. And so the really cool thing about making them yourself is that if you break it, if you like say you're flying it, you're having a really good time, and then all of a sudden you break the motor or you break a propeller, because you were the one that put it together and you built it, you're gonna know just exactly how to fix it, and you're gonna be able to break it and keep fixing it and keep having fun. So yeah, I build and break drones all the time.
Awesome. All right, Strong has a question for you.
How much does it cost to build some of the drones?
Yeah, absolutely. And so this is the best part that you can tell your parents, right? We don't want to give them an exact number, but we can say, hey, mom, hey, dad, it's less than $200. It's less than the new PS5. It's less than a Nintendo Switch. So you can tell mom and dad, say, hey, it can be anywhere from $100 to $200. So you can either get something like this that doesn't have a camera on it, and it's maybe not too expensive. You can get something like this for maybe $30 to $50. So that's not too bad. You're probably going to have a better chance with that. But if you want something a little bit cooler, then you can say, hey, mom, hey, dad, it's a little bit more expensive, but it's a lot cooler than the cheaper ones.
No.
Thank you.
Yeah, absolutely.
Anybody else? You got another one? Okay, Dalton's got one more. I think we're about out of questions. You guys have done awesome.
What's the most expensive drone you've ever actually made?
So the most expensive drone that I've ever made was a $300 drone. And so the cool thing about drones is the more expensive it is, the more you can do with it. So if it's $300, that has so I don't know if you guys have ever flown an RC helicopter, but I used to fly them over my neighbor's fence all the time, and that would make them super, super upset. And so with the more expensive drones, you can actually program it to where if you crash it, the drone flips over and then flies back to you. So having the camera on the drone, having the ability to kind of like flip over and then fly back home, and as well as, let's see, having some really strong motors on there. So that's a little bit more of the most expensive drone that I've built, but it's also got a lot more features on it.
Wait, do you know how the VR drones work?
The VR drones?
The VR drones, how do you like control those?
Yeah, and so from that quadcopter diagram that we showed you, so there's a VTX or video transmitter signal. That VTX communicates with our flight controller, which is the brain of our drone. And so again, it's just one big systems control. So the camera is connected to the flight controller, and the VTX is connected to the flight controller. So as the camera, kind of like on your phone, as the camera is picking up video, it's sending it back through the flight controller and the VTX. And then that signal is going from the VTX to the goggles. And so that's how you're able to see what the drone sees.
Do you have any controllers with you?
What's that?
Do you have any controllers? Yeah.
Yeah.
Camera.
Yeah, and so that's our transmitter or our radio controller. And if you can see here, it's actually got a couple of different switches on it. And you can actually, and a lot of this is based in programming. So you can actually program the switches to, either flip over. Like one switch can be assigned to make the drone flip over. One switch can be assigned to make the drone fly back to you. One switch can be assigned to disarm the drone. Like, again, say you're flying inside and you just get a little bit too close to mom or a little bit too close to brother or sister. And you're like, no, it's not supposed to be that close. So you hit one of those switches and the drone immediately drops from the air. That's our emergency kill switch. We also call that our oh snap button.
Colby, a few others have questions.
That's perfectly fine. Absolutely.
Colby,
I like to play the game with the burrito.
Colby's got a question here for you.
What made you want to start working with drones?
Oh my goodness, I'm so glad you asked. So I actually started off flying one of these right here. So I got a drone like this for Christmas. And again, like I said, I broke it a whole lot. And I don't know how you guys' parents are, but my parents are like, you get one, if you break it, you know, like it's up to you. And so with that being said, I had to fix this drone that I was always breaking. And so by fixing the drone, I learned a little bit more about how it worked. And it became a lot easier for me to work on drones. So by learning how to work on drones and how to fix drones, I actually became a drone and engineering instructor. And so I actually taught robotics and drone technology while I was in junior high school for a little while. And so with the more you know about drones, the more complicated projects you can do. So that's how I got into drones. So I went from something simple like this, like again, it was a $30, $50 drone, to something a little bit more advanced like this. So now I get to go to school and work on big drones like this. So like, it's really, really awesome that you guys are starting to work with drones right now, because by the time you guys get to where I am, you guys are going to be able to do a whole lot more with these drones than I ever did. So that's how I got started. I hope that answers your question.
Yeah, thank you. Milam has a question.
So that drone in the back with that one, what does the thing around it do?
So that is our cage. As Dr. Votion mentioned, we fly this really, really big drone inside. And so the big thing that you have to remember going from a small drone to a big drone, the propellers get like a lot more dangerous. So have you ever seen your ceiling fan, you know, spinning really, really fast? Drone propellers spin, you know, 1,000 times faster than that. So our cage actually protects us. So where it's okay to crash into the wall with something like this, because it's not going to do too much damage, our cage actually protects us, our environment, and the drone itself from, you know, spinning out of control, because our tests don't exactly always go the way that they're supposed to. But that's a really cool thing about learning and working with drones. Like sometimes it works, but whenever it doesn't, you're able to learn why it didn't work and then fix that. And then hopefully it should work next time.
Natanya has a question.
Have you ever built your own prototype of a drone from scratch?
I'm sorry?
Have you ever built your own prototype of a drone from scratch?
Yeah, so I'm actually really into 3D printing. And so the cool thing about drones is all of these drones, if you notice, they come in different shapes and different sizes, but their parts are the same. So you have motors, you have your propellers, you have some sort of brain or flight controller, and some way of controlling the speed. And so as long as you have those main components, you can make a drone out of wood and attach the motors to it. You can 3D print your own frames and simply attach those parts to them. Or you can do something a little bit more complicated, like using a carbon fiber frame. That carbon fiber frame is going to be really strong and really durable. And that's sort of what this quadcopter right here is made out of. That way it's able to brace itself because like the bigger drones have bigger crashes, you need a material that's going to be strong enough to support those crashes. And so that's sort of what I've done in my free time is I've actually worked with 3D printers to make my own drone frames. And so again, by knowing how to build and knowing how to fix your own drones and being able to 3D print them, now you don't have to buy those drones anymore. You can make them all in your home.
We have 2 more questions. You got a couple
Absolutely.
minutes? Okay.
Yeah, absolutely.
Back for number 2.
What is the biggest drone you've ever worked on?
This is actually the biggest drone that I've ever worked on. It's really, really cool. And being a college student and going from something small to something big like this, there is a really steep learning curve, which is why it's very, very important to learn the fundamentals of drone. So that's why you start with something small like this. That way you understand how to control it and how to fix it and how to build it. So now these parts are a lot more expensive. So if I break them, I'm going to get into a lot of trouble. But it's really, really cool because I have that that foundational knowledge of working with smaller drones. And like I told you guys, like these are the same parts just on a bigger scale. So I'm very, very fortunate to say that this is going to be the biggest drone that I've worked on. But hopefully I hope to work on bigger and better projects in the future. But I'm still learning as well. So I'm absolutely taking advantage of what my school has to offer. And I highly encourage you guys to do the same as well.
Dr. Votion, any bigger ones for you?
No, I'm definitely afraid of bigger ones. So.
Okay, one last question from Strong.
What drone has the longest battery length, and which drone has the smallest that you've made?
Yeah, so Dr. Votion mentioned the limitations of drones being the size of their batteries. So with a drone like this, you have to imagine that the battery has to be able to fit on top of or within inside of this drone. So this drone has a really small battery and it lasts about 4 to 5 minutes. This drone behind me has a much larger battery because the parts are so much bigger, so they require more power in order to run. And so the biggest drones and the biggest power sources that there currently are the ones being used in the military. So if you guys remember, Dr. Votion showed you guys the one of a man standing next to the drone. Even though it's like really, really big, that's still technically a drone. And because it's really, really big, you have to scale up all of those parts. So you're not dealing with small batteries anymore because a small battery is not going to be able to power a drone that large. So the military drones are actually going to be the biggest battery users that I'm aware of at this particular time. Like the drones that big that a man standing next to him kind of looks like a little kid. Yeah, those are going to have like the biggest batteries because they have the biggest motors and the biggest bodies. Yeah, right. Really, really big.
Right, that's our last question. Do you guys have anything you need to tell us?
Nothing on my end. Any last words or words of advice or suggestions for the students to close out?
No, I really enjoyed this session, and I hope everybody learned a little more about drones that they didn't know before. And I really hope that you find some interest in STEM, even if it's not drones, but something STEM related should take you very far. But if you don't go into STEM, that's fine too. Just as long as anything that you go into that you're really interested in what you're doing.
Oh, you see, I'm a little bit closer. So I'm going to say my advice would be, guys, Christmas is coming up. These bad boys are not too expensive. And I'm telling you guys just the translation from something small to something big like this. So if you guys want a career and a job to where you get to play with really big, really expensive toys all day, I highly encourage you guys to get involved with either drone technology of something this size and then working your way up, or there are really good robotics kits out there as well that kind of help you get your hands on it. If you're curious and you just don't know where to start, those kits have instructions and lots of YouTube videos that you're able to follow as well. So even if you don't buy the kit itself, I highly recommend that you guys go onto YouTube and do a little bit of research and exploring and just type in drone technology or DIY or do-it-yourself drones. And you guys were talking about drones that you can make at home or build yourself. So YouTube is going to be a really good, really free way to get started learning a little bit more about drone technology and robotics and things of that nature.
Let me interject here. Sorry, we need to close it down. First, I want to thank all the participants, to our presenter, to Carlos, and especially to the students and the school at Frankfort Elementary in Frankfort, Missouri. You all have just been great. Secondly, I want to wish you all a very happy Thanksgiving in a couple of days, a safe and happy and warm Thanksgiving. Third, I'm no drone specialist, but I'll tell you what my favorite drone is, and it's really a drone, and that is the helicopter that NASA put on Mars. That is a drone. Do a Google search, look it up. And we don't have time to go over it now, but I've been hearing a lot about little batteries and battery life. And NASA couldn't have possibly put a big enough battery in there for all the times that drone flew and has been flying. So there must be some alternative form of energy going to that helicopter, and we'd love to hear more about that another time. So our virtual presentations will take a break for the rest of this year, and our next one will be on January 11th, and we will be talking about biology and aerospace. So happy Thanksgiving, happy holidays, and thank you all, and thank you, Carlos.